All right, this is the continuation of question number 4 on homework 6. Says a rifle with a muzzle velocity of blah 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 is fired from ground level at an angle of blah blah blah. We already answered in part A of this. What's the velocity, magnitude, and direction at its maximum height? How many seconds does it take for it to reach its maximum height? And then what is the maximum height of the bullet? The whole point of the first part of this is for you guys to recognize that at its maximum height, the velocity in the y direction is 0. It maintains its initial velocity in the x direction throughout the entirety of its trajectory. So part A is just whatever the x component of the velocity is, and 0 degrees to the horizontal. How many seconds does it take for it to reach it? We did that, and then the maximum height with our kinematic equations. The last one here says D. Find the following just before the bullet hits the ground. And I realize that it's kind of hard to tell, but this is Vx, this is going to be Vy, and then this is just the velocity, which is the resultant velocity, or the square root of the sum of the squares of these two. And then it's the angle is what we're looking for. So let's go ahead and get started with the example that we were using before. I went ahead and changed the velocity initial to 948 meters per second, and the angle to 62 degrees. So if we want to find the following just before the bullet hits the ground, it says Vx, Vy, V, and theta. And these are actually going to kind of roll by really fast. So what I'm looking at is, I'm going to go ahead and write this down. D, Vx, Vy, V, and theta. So a couple things that we should notice here. In the trajectory that we had up here at the beginning, what we do know is that since we're launching it into the air with a velocity of 837.03 meters per second, it is going to come back down with that same velocity in the opposite direction. I don't know how well you guys are going to be able to read this, but that says 837.03 as well. So what you should note is that your final velocity is exactly the same, but in the opposite direction of the initial velocity. So if we're going to draw this, and our Vx doesn't change the entire time. So, I mean, it's pretty straightforward. Vx equals whatever you found before, 445.06 meters per second. Done. Vy equals negative 837.03 meters per second. Done. Right? So the next thing we're going to look at is V. Well, our final velocity is actually going to be the same as the initial velocity, except it's headed down. So the resultant vector is going to be 948 meters per second. All right. And the very last one says theta equals question mark. Well, what we're going to find is that if we draw those out, let's see, here's our triangle. It's moving this way, and it's moving very much that way. Vx is 445. This one is negative 837.03. You don't actually have to include the negative since you already have the arrow indicating direction pointing down. So what you should note is that this angle here is the same as this angle here, only it's negative. So theta equals negative 62 degrees. There's actually absolutely no calculation required for the last part of that. Okay?